In part 2, we simplified our code to handle bounces off the top and bottom of the graphics window. Here's the program just as we left it. Remembering what we did at the end of part 2, let's now combine the two tests to make for a shorter program that's also easier to debug and maintain. I'm just going to copy the second clause. I'm going to come back up to the first one, wrap it in parentheses, because I know I'm going to type or, and then paste the second clause. Then we'll get rid of this whole if statement, and I'll run this. And we should get the very same behavior we had before. We bounce off the bottom, and I hope we bounce off the top, and then we go off the right-hand side. So great. Let's now fix that bounce off the right-hand side. Here's where we left things, and now we're going to follow the identical strategy, but we're going to use CX and SX and width instead of CY, SY, and height. So we can use the existing code as a template for the new lines. Let's do it. I'll open it up. I'll notice that the horizontal extent goes from 0 to width. So my test is if either CX is greater than width, if the ball is off the right-hand side, or the center of the ball is to the left of 0. In other words, it's off the left-hand side, something. What's the something? We'll just flip the X speed around. So now instead of moving right, it goes left, or vice versa. And then we correct for the position of the ball by adding 2 times the speed. These two if statements have the same structure, but notice that they're not really repeating one another because they're using different sets of variables. So I won't try to scrunch them together. But if I found myself repeating this structure many times over and over again, I would probably try to find a different way to write things to get rid of even this much repetition. But these don't really repeat, so they're just fine. Let's try them out. So here's the program where we left it. I'll just say if CX is greater than width, or CX, capital CX is less than 0. I know I'm going to flip the speed around. SX is minus SX. Whoops, make sure I'm typing X's here. 2 times SX. So that's what we saw on the slide. Let's run it and see what happens. There we are. We bounce off the bottom. And we bounce off the top. We bounce off the right. And if we hang on a moment, I think we're going to confirm that we're going to bounce off the left. Now you may notice that the ball is actually disappearing a little bit off of each of the 4 sides. And that's because we're testing the center of the ball, not the edges. If you want to make a more refined version of this program, I invite you to dig in, think about it for a while. It's not an easy problem. Once you see what to do, it's straightforward. But think it through and try to figure out how to catch if the top of the ball is off the top of the screen. If the right of the ball is off the right-hand side, the bottom is below the bottom, or the left side of the ball is off the left. Just for fun, I'll crank up the radius and leave a trail behind. So let's make the radius much bigger. Let's say 60. And I'll clear the background so we leave a trail. And we'll run it. And here's our big old bouncing ball, leaving a trail behind. This is a technique that you're going to find yourself using over and over in lots of different situations. So it's worth getting a handle on. I suggest that you take the code that I've given you, work on it yourself, change it, again, try to figure out how to prevent the ball from halfway disappearing, and maybe even change the policy, change the design. Maybe when the ball bounces, it should do something else. Well, it's up to you. Make up what that something else should be, and then make it happen.